Hello everyone. So in this today video lecture, we will discuss about different join operations in case of your SQL programming. So in the last video lecture, we have discussed about how correlated nested query works with the help of exist and not exist. So in this we will work on this join operations, different types of joins and outer joins. Anyhow, already you might have learned this joins in relational algebra, and already in previous examples also in case of your exist and not exist, in case of nested queries, we have already used this join indirectly, but today we will understand how to use that case of writing a query. So join operations can, what we have learned till now is can be done in the where clause. Say for example, retrieve the names of every employee who work for IS department is the question. So I have taken a simple example of two tables, employee and department here. So it is asking for the names of every employee who work for IS department. So I am trying to get the relationship between an employee and a department through works for. So what we can do is, say if I write a query, select what I want name of an employee. So let me take the employee name, okay, from EMP E and department D in case of common attributes. Next, where, see, now when the question was asked with respect to IS department, department name is in department table and employee name what they are asking is in employee table, right? So first thing you are supposed to do is create a relation. How to join this table based on the common attribute. So in employee table, SSN is the primary key, and in department table, MGRSN is the foreign key. Meanwhile, in department table, department number is the primary key. In employee, D small, this is the foreign key to refer which employee is working in which department. So now the question is asked with respect to works for or manager. It is asked with respect to works for, because see, retrieve the names of every employee who work. It's not about mentioning the question about the manager here. So what we need to do here is we need to join these two tables based on the works for condition, that is department number. Hope you are able to grasp this. See, what I am telling actually here is the question is asked in such a way that retrieve a name of an employee who works for a IS department. The query is being given in that way. So the working for condition is given here. See, department number, employee number 1 works in department number 10, 2 works in 11. So this is the foreign key which mentioned to be this. So now I need to join this two, where with respect to the department number, anyhow we have two different representation. Aliasing was not required, where let me do it anyhow. E dot department number equals, okay, D dot department number, and okay, condition is, so after joining, when I join this two table becomes one big table. So let me write that, the attributes next, and where D name equals IS. So once we have D name equal to IS, the condition has been given here. Now what happens in case of here is, I will be having a very big table now with attributes SSN, E name, salary, so and so, then followed by D number, D name, so all the attributes of both the tables together. Now to this table, the output join table, what we have joined, we are going to put condition department name equal to IS. So only case of this corresponding rows, say for example, when I do a match, first I will look for 10, its 10 is here, yes, so replace 1 A 10,000 10 with the department name CS. Again I have 11, replace. So this way I will keep on joining it. After joining, wherever I find the department name as IS, only those rows will be selected. In those rows, what I want the employee name. So the output will be what now? In case of IS department, 11 is twice, so B and C will be selected as an output. Okay, so this is what you already have learnt it. Now what I wanted to convey here is, in this particular topic join, the same join operation what we have done. Actually this is called as equi-join because we have used equality operator to match the condition of two tables. The same type of join operation can be done in the from clause also. Anyhow, this is already, you people have been aware of it by now because we have already discussed this a number of times, this equi-join. So what is that other way of joining two tables is? From EMP join department on, you are supposed to give the condition. While giving the condition on clause, look for what are common in both the tables. Right now we are joining with respect to what? The works for, so department number and department number. On department number equals department number. D is small in case of foreign key, so I have given. There are two different representations. If these two had same representation, then you are supposed to do employee join department space D on D dot department number equal to E dot department number if has been done. If in case of what? If two tables have a same, the primary key and the foreign key, if they had a same representation, then we have done that aliasing part. As it is not, in this case there are two different representations, so it is not required here. Okay, so employee join department on department equal to department number. Next condition is what? Same, that is remains as it is. That is D name equal to IS. So this type of join is somewhat equal to the previous example of join in the where clause. So this is what I wanted to convey in this particular topic of join tables. That is, not only we can join the two tables in by using a where clause, we can also join in the from clause by using this join keyword between two different tables by giving a on condition. On speaks about whether the two table have a common attribute with the same compatible type, but they have different representation, so you can specify it. Okay. Now the question is, what if they have two different table have a same representation for the case of primary key and foreign key. Say for example, in case of foreign key also, I had department number here itself. So on that case, so this is what actually, it's a equi-join. So you have, this is equivalent to the where clause joining. Okay. Now we will see one more type of join, that is from employee EMP natural join DEP where D name equals IS. So if you do this type of join, is the case where you need not want the attributes to have a two different representations. So primary key department number DNO D caps, foreign key also DNO. So when we have same representation of an attribute in the primary key as well as in the foreign key, we can do this natural join. Okay, you might have seen in linear algebra doing that. In linear algebra we used this one for join operation for equi-join, and in case of natural join we were using this asterisk. The same way we need to use this natural join keyword in front between the two different relations, employee natural join department, where department name equal to IS, in the sense this two table will be joined on the common attribute department number. Okay. So if I'll do one thing, I'll just write down the one instance where in case it will be better understand for you all, where department name equal to IS. What will be the difference also, let me tell. That is, first we have SSN, then we have E name, salary, department number, department name, and then we have MGR SSN. Okay. Now, what difference you will find between a natural join and equijoin, you might be aware of by now. That is, whenever I use a natural join, when I do this natural join, as you can see, the representation of department number is same in both the tables. The resultant table will be having only once. The occurrences of the common attribute will be only once. Say for example, if I had D small in this case of foreign key here, I would have got department number again in the intermediate after joining. After condition and after projection, anyhow all the attributes are eliminated for us. But when you apply join, this is how the table will be looking for you. That is the natural join. So SSN, in the case of first SSN, we are joining with respect to what? Employee, department. What is common here? Department number. So 10. So first the department details has to be filled. 10 CS1. Do I have 10 there? Yes. That is 1A 10,000. Okay. Next, any more 10s? No. Next 11. Is 11 is there? Yes. So write on the primary key table first. 11 IS 2. So is any 11 here? Yes. The second row is also 11. So write down 2B 20,000 11. Okay. Any more 11? Yes, we have one more 11. So write down. So this should be repeated again. 11 IS2, same thing, because in the foreign key table there is one more 11 being referred. So write down this now. 3 C name 15,000. Okay. Any more 11? No. Next 12. 12 is here. Yes. So write down 12 CV 4 MGR SSN. The details of 12 is 4 on from this table. 4 D 20,000 22. Sorry. Okay. So this is what the table you get after applying the join operation. Only this one. Next we have a condition and then projection. What is the condition? Wherever the department name is IS, this row and this row will be selected. From these two rows, project what? Only the employee name, that is B and C. So B and C will be displayed as output to you. But what you want to understand from this here is, in case of join, the first thing is you can also join from the from clause, not only in the where clause. That is the first thing you need to understand. The next thing is, in the from clause we can do equijoin as well as natural join. Equijoin in the sense, employee join keyword department on what condition? The previously we have done it. When you do that, the attribute which is common in these two tables, DNO and DNO, will be do two different representations. Both will occur in the output table after joining. But when you use a natural join, make sure that they do have a same representation. Then you can apply the natural join this way and get the output. So this is how the join operation works. You need to visualize this kind of values to be being considered whenever you are applying the join. Okay. So this is all about your join tables in SQL in case of equijoin and natural join. Next we will move on to the outer join operation. So we have just seen that equijoin, and we have seen equijoin is also somewhat similar to the inner join, the natural join. The natural join. Now we will see the outer join. See, outer join normally will be used in certain conditions where we expect some of the values irrespective of joining. If it does not have a matching value in the opposite table, still I want to occur that particular row into the resultant table. So let me tell with an example so it will be clear for you all. So first of all, outer join has three different variants, that is we have left outer join, then we have right, then we have full outer join. Okay. Anyhow, all this different left, right and full outer join you already have learnt in relational algebra. Anyhow, I will just brush away with the same example what is there on the board. Normally this left and right outer join are normally applied on the tables where we have this primary key and foreign key relation, whereas full outer join normally tends to have two tables to be joined without that primary foreign key relation, because we want both the sides value be not being matched also. We will see that now. So what is this left outer join? How do you write a query for it in SQL? Say for example, I need to do a left outer join on employee in a department. Okay, on some condition, say select from EMP left outer join, left outer join. So whenever you are specifying that, make sure you specify the first table, resultant table on the left hand side, then the resultant on the other table on the right hand side by specifying the condition. If you want, you can create a aliasing also there. So from EMP left outer join with what table? Department. If you want, you can have aliasing here, employee as E, department as D, then employee left outer join department on what? Now I am expecting, say for example, I want to display the name of employees who are the managers. Okay. Now on SSN equals MGR SSN. SSN equal to MGR SSN. I am specifying the joining condition here. Where do you have any other condition for the where clause to be specified? We don't have any condition. Done. So I want the name of employees after joining this. Okay. So now what should happen? How the query has to be executed? Let us understand with an example. So this is first, let us understand the syntax to how do you write this left outer join, what we were writing in relational algebra like this. This was the join. If I use this was the left outer join there. The same way the left outer join, you can use the uppercase as a denotion for this for the time in case of specifying left outer join, we would have used the uppercase letters. So if you can easily differentiate the relation name and the keywords being present here. So I applied a left outer join on these two tables. I want the names of employees who are managers. In case of irrespective whether they are manager or not, I want the names of employees to be displayed. Now when I do a join operation, what happens? The resultant table will look like this. The result is what you make you to understand what exactly we are speaking about the outer joins. Salary, department number, okay, D name, MGR SSN. Okay, so we are doing SSN, MGR SSN. SSN 1 is here 1A 10,000, okay, and department number is 10, department name is CS, and MGR SSN is 1. So 1 is present in the primary key table, so I have applied it. Okay, this is somewhat similar to your previous join operation, that is equijoin or natural join. Next I have 2. So 2 is present here, yes, it is present in the foreign key table also. So please write the 2 details. To first write the primary key table, 2B 20,000 11, okay, then the branch 11 is IS and 2. Okay, next we have this 3 is 2 is repeated more than once, no, only once. So 3 is present here, no, 3 is not present here. But listen now carefully, irrespective if there is a left outer join, whenever we do, if there is a matching element on the right hand side table or not, it doesn't matter to us, but the value has to be present in the output table, that is 3 C 15,000 11. Okay, whereas the department number, the department name and MGRSSN of this table, department table, should be filled with null, null, null. So this is called as a left outer join, where we have the left hand side values being present in the resultant table. If there is no match for a left hand side table on the right hand side table, there is a right hand side table is a department, it doesn't matters to us, we will just write it what? Null, null. So it says that he is not a manager for any of the department. So there is no details for him for being a manager. Whom? The employee number, employee name as 3 or the SSN as 3. Okay, C is the name. Next we have 4. So 4 is present here, as we have 4 being present here. So 4 D 22,000. Then we have this department number for 4 as 12, civil, MGRSN is 4. So 1 is matched 1, 2 is 2, 3 is no, null, 4 is matched 4. So this is called as left outer join. If the same condition if I applied in normal join operation, say if equijoin or normal natural join operation, this row was not coming in the output, only we had these 3 rows, because only 1, 2 and 4 are the managers, 3 is not a manager. But when you do a left outer join, irrespective of whatever the case been given, left hand side condition will be present. If there is no matching on the right hand side, not also. Okay, the question which can be asked for this kind of query is select the details of employees with respect to whether they are managers or not managers. So both the conditions, like employee who are managers and not managers, display their names if they ask, so you can get details. So finally I am displaying the E name, so I will get A, B, C, D. So I will get the names of all the employees irrespective of whether they are managers or not managers. So this is called as left outer join. Left hand side tables values will be present, but the corresponding right hand side values will be filled up with nulls if there is no match, only on the case. Okay, that is what is left outer join. Okay, so let us understand what is this right outer join now. Same example. From EMP right outer join department on. Okay, so I will join now with with the department number. So as they both have the same representation, sorry, I need to give aliasing here, where employee as E, okay, right outer join with which table? Department. So department as D, okay, on E dot department number equals D dot department number. As they both had a same representation, I need to do aliasing, as I said before, because I can't directly go with natural, because we are discussing with outer joins now. So this is the left outer join concept. So when a question say for example, if they ask display the details of employees who are working and who are not working for some department, means I want details of all the employees. I want the employees who have been assigned to some department and who are not been assigned to any department for working. So I want details of all the employees who have been assigned to different departments. So if that is a question being asked, I want to display the employee names. How does a join table looks like? See, I am not writing this output, I am just writing how the join operation happens. Okay. So now, first you need to look for what is the common attribute we have taken here. That is, we have taken the department number, which is the primary key table now, the department table. So which is on the right hand side now. This is on the right hand, this is on the left hand side, right? Now, first fill of the department number 10, CS1, which we are joined in. Okay. Now, when we have this 10 being present here, does 10 is present in the output table, sorry, in the foreign key table? Yes, it is there. So fill it now, because I'm looking for equality condition where the 10 is present there. As it is present, to fill the details 10A 10,000. Okay. Next we have 11. So fill the primary key table first. 11 IS 2 as it is 11 present here, as it is present once. So fill the details 2 B 20,000. Okay. Department number is 11. Next, any more 11s? Yes, we have still one more 11 is there. So copy the same thing, this as it is 11 IS2. Now for this 11, replace this one now, that is 3 C 15,000. Okay, good. Now next we have 12. So write down 12 CV 4. Is 12 is present here, as we have 12 present here, the fourth row 4 D and 22,000. Okay. Next we have 13. So write down as it is in the primary key table, 13 ME, and there is no manager for this. Fine. So 13 ME and no manager. Now the 13 is present in the foreign key table. No, 13 is not been assigned for, with any employees. Right now 13 department 13 is no employees. So what will happen now? All the attributes, that is SSN, employee name, salary, will be given null for the details of 13. So 13. Okay. So this is called as right outer join, where we have the right hand side attribute being present in the resultant table. For the left, if there is no match on the left hand side table, do fill in the null. Okay. So that says that the department number 13 is not assigned with any employees by now, till now. Okay, that is the reason we have this null. So if I ask you to display the employee name of employees who have been working and not working for any department, means I'll get all the details from 1 to 4. But in case of department number 13, we don't have any employee been assigned. Okay, so this is called as a right outer join. The right hand side table, all the tuples will come in the relation, but if there is no matching tuple in the right hand side, left hand side table, we have null on the left hand side. So if you have null on the left hand side table, is called as right outer join. Okay. So as I mentioned, the question can be framed in such a way here is the details of employees irrespective of whether they are working or not working for any department. So I have the list of all the department 10, 11, 12 and 13, but all are not been assigned with employees, but all are actually the departments. Okay. So this way this type of questions can be framed when using the left outer join and right outer join. Okay. Anyhow, we have already seen this in relational algebra. I just thought of go through it, the syntax actually what you wanted to understand. Okay. And lastly, we have this full outer join. Let us understand that. So in case of full outer join, what we have to know is, sometimes it will be difficult to have a full outer join condition with the primary key and foreign key. Why? Because you know that whatever the values I fill in the foreign key should be present in the primary key, right? And the same way, whatever the values I need to fill in the foreign key should be present in the primary key. So sometimes we can't apply this full outer join in the primary key foreign key relation, but in sometimes some relatives we have partial key representation. So I'll show you. Say for example, I have a table. Let me name it as R1. F name, L name, something like this, and R2, Fn, Ln. So A, B, I'll take some 4 names. Now, so how to write this left outer join? Say, sorry, the full outer join. Select a respective star from R1, okay, full outer join with the R2. Now be careful while using this outer, especially the full outer join, because full outer join conditions wherein which we can apply it on two relations for the given condition. Say select star from R1 full outer join R2. So now I need to specify what is the condition for that, on what attribute I am supposed to do a full outer join. So on, so let me take it as f name equal to fn. So this is the query what has been given. Okay, so select star from R1 full outer join R2 on f name equal to fn, this equal to this. Now, so I'll just rub this, highlight here, select star from R1 full outer join, okay, R2 on f name equals fn. Now the resultant table will be what? Okay, I am given star, I want all the attributes, that is f name, L name, fn, ln. Now the full outer join is something like a combination of both left outer join and right outer join. First we will find out what is the matching between two tables. Okay, then if there is no match for the left hand side in the right hand side table, put null. Same way, if there is no match on the right hand side table to the left hand side table, put null values. That is what the full outer join is meant to be. Let us see that example, so it will be clear, we will get a clear picture of what exactly I am telling. So f name with f name, A is present here, no. So write down A, B. First write down the left hand side table, because that is a primary key here and this is a primary key in that case. So fn, there is no A, so put null and null, because there is no A, B, first name as A and second name as B in fn and ln in the table R2. Next, CD is there, CD we have put up here, the CD, yes, there is a matching, so write down CD, as we have a matched value on both the tables, CD is present here. Okay. Next, on that case CD is anyhow is present, if you want you can write one more row of this, but when it comes to the EF, okay, this is on the right hand side table which is not present on the left hand table, fill in the null values. Okay, you can again repeat this CD values here for the case of joining R2 with R1 again. Now this is called as full outer join. So as you can see here, common values are present, what is present in left hand side, what is not present in right hand side is present, what is present in right, what is not present on the left is also present. So altogether full outer join, irrespective whether they have a common values or not, in both the instances on the participating entities or the participating relation left and right will be taken place. This is called as full outer join. So the syntax is full outer join is a keyword with the caps will be used in writing the relational algebraic queries. Sorry, not relational algebra, SQL queries in this case. Okay, so this is called as full outer join. So we have learnt with respect to the natural join, and we have learnt in case of join we use this join keyword in the from clause. Whatever we have learnt in respect to the from clause itself. So if you want, you can have a proper representation of it. We have join, then we have this natural join, if you want a proper representation of it. Okay, then we have this left outer join, then right outer join, then lastly full outer join. So join, all this are used in from clause, not where clause. Where clause normally we have already learned equality operator is being used. If you want to perform this join operations in from clause while writing SQL queries, these are the possibilities we have: join, natural join, left outer join, right outer join, and full outer join. Normally outer join conditions are specified in the from clause itself when it comes to the SQL being written. Okay. So this join operations can be applied not only on 2 tables, can also be on 3 tables. So if you have multiple tables, the condition goes on like this. Say for example, for R1 I have one more table called as R3 here. So R1 full outer join with R2 on this condition, then put the braces for this, again full outer join with the R3. So this way the conditions can be extended not only for outer join, for both natural join as well as for equi-join, which is joined in from clause. Okay. So in today's video lecture we have discussed about equi-join, the natural join, equi-join, how it is performed in where clause, how it is to be performed in the from clause, then the natural join, we are going to use the keyword natural join as it is the case. Then we have left outer join, we discussed about that, the example, then we discussed right outer join, followed by we discuss about full outer join, where the case as you can see on the board. Okay. So this is all about today's lecture. Thank you all.